We want to start with a projectile and physics. The first thing we are going to look at is the definition. Projectile is a particle sent into the space whose motion is under the influence of gravity. Is under the influence of gravity. That is what we call a projectile. Then immediately after that, we have trajectory of a projectile. Trajectory of a projectile. There's another one called the trajectory of a projectile. This is the direction. This is the direction of the path taken by a projectile. This is the direction of the path taken by a projectile, which is usually parabolic in shape. What we are saying is this. It later learn. This is parabolic. So this is the path taken. This is the trajectory of that projectile. That's the definition as we have it in WAHEC. Define projectile. What is a trajectory of a projectile? Then what are the examples of projectile used in the daily life? So let's see examples of a projectile. Used in A. Let's see warfare. E.g., we talk of a short arrow. A short arrow is there. A projected missile is there. 3. We talk of a short arrow. We have mentioned that. A projected missile. We have mentioned that. Which other one? Which other one? No, a short arrow. This course is under a fired bullets. Fired bullets from the gun. A fired bullet. These are used in the warfare. Then let's be. We say projectile used in sports. A short, a thrown discus. 2. A kicked ball, football. A kicked football, a thrown javelin, and etc. That is what we have. Then immediately after that, we have types of projectile. Types of projectile. 1. We want to see projectile, one-dimensional projectile. Projectile in one dimension, one-dimensional projectile. One-dimensional projectile. We have two-dimensional projectile. Projectile in 2 dimensions. Two-dimensional projectile. These are the 2 types of projectile we have. One-dimensional projectile, 2-dimensional projectile. Immediately after that, we take it one by one. We look at one-dimensional projectile. one-dimensional projectile, one-dimensional projectile, one-dimensional projectile. Under one-dimensional projectile, we have is divided into two as well. We have vertical motion, when something is thrown vertically upward or downward, vertical motion. So which can be upward motion. It can be upward motion when something is thrown vertically upward. It can be downward motion. These are the two types of motions under vertical motion. Then two, we have horizontal motion. Horizontal motion. These are different types of motion under one-dimensional projectile. So we are going to take it one upward motion. Upward motion. Let's see upward motion. Upward motion. A body or a particle projected vertically upward as the following parameters. It is characterized by the following parameters. One, the first parameters there is u is never equals to 0 meter per second, but maximum. We say that v is equal to 0 meter per second at maximum height. Final velocity is equal to 0 at maximum height. Then 3, we say that s is equal to, anyway you see s is equal to our h, height, and acceleration is equal to that of gravity, which is equal to minus g. When a body is thrown vertically upward, it's moving against gravity, so it will be minus g. It is minus g. These are the parameters you are expected to know. So under upward motion, you are to find the time when something is thrown vertically upward. What will be the time to reach the maximum height? So we want to look at time taken to reach the maximum height. Time taken to reach the maximum height. That is what we want to consider. Time taken to reach the maximum height, small t. Then from equation of motion, v is equals to u plus at. From all these parameters, so while we are dealing with maximum height, at maximum height, final velocity is equal to 0. Initial is never equals to 0. But a here is minus g. That's why we call it minus gt. Transfer this to this side to be gt9 is equals to u. Then t9 is equals to u divided by g. In one dimension, this is the formula for finding time taken to reach the maximum height. T is equals to u plus u divided by g. When a body is thrown vertically upward, the maximum height. That is what we have derived here. The next thing is to look for time, total time of flight. This is the total time spent in air. This is the total time a projectile spent in air, which is equals to, it's given to be t. It's always equals to time taken for upward motion plus time taken for downward motion. So to be t plus small t. So to be t is equals to 2t. So is equals to t9 is equals to 2, because t, recall that t is equals to u all over g. We have derived it. So put it here to be 2u all over g. This is the time of flight, total time spent in air. That's the formula for that. Immediately after that, we want to see what is the maximum height attained. Maximum height attained or reached. Maximum height attained or reached. Maximum height attained or reached. So we are still under upward motion. So from you can use v square is equals to u square plus 2as to derive it, where v at maximum height v is equal to 0 square. This one is u square. Remember that a is equals to minus g. So this one will be minus 2g, s is h. Transfer this to this side. This will be 0 is equals to u square minus 2gh. Now transfer 2gh is equals to u square. What is h now? U square divided by 2g. This is the formula for finding the maximum height when a body is projected vertically upward. This is the formula for calculating maximum height. You may be required to use this, no problem, to use s is equals to ut plus half at square to derive it. If you are going to get the same answer. S now is h. U, I don't know, dot. Our t, remember we have derived to be u over g. This is u all over g plus half times minus g, then t squared, u all over g squared. So this one will be h is equals to u squared all over g. This minus will come here, minus g all over 2 times u squared all over g squared. G will cancel 1. That is what we have here. H now is equals to u squared all over g minus u squared all over 2g. You find the SCM. SCM is 2g. G here will give you 2 times, that is 2u squared minus 2g, that is u squared. When you subtract, you have h9 is equals to u squared all over 2g. You are going to get the same thing. You either use this formula or use this equation of motion, you are going to get the same formula. So this is the time taken to calculate the maximum height attained. This is the formula. This is the formula. Upward motion. We call it velocity time graph for upward motion. For a body projected vertically upward. How does it look like? Velocity time graph is a graph of velocity in meter per second against time in seconds. That is what we call velocity time graph. So when you sketch this graph for upward, is like this. The graph looks like this. This is the graph of velocity against time for upward motion. You know, I said the other time, initial velocity is not 0, the final velocity is 0 for upward motion. What happens in upward motion? Velocity will continue to decrease with time. Velocity decreases with time for a body projected vertically upward until it attains the maximum height where the velocity is 0, where the velocity is 0, meaning is 0 meter per seconds at maximum height. So that's what happens to velocity of a body projected vertically upward with time. Velocity decreases with time. Velocity decreases as you have shown in the diagram here. With example, you understand the meaning of velocity is 0 at maximum height. We are going to look at 1 or 2 example 1. A particle or a body is projected vertically upward with a speed of 50 meter per second. The body is projected vertically upward with a speed of 50 meter per second, or at a speed of 50 meter per second. Calculate the time taken to reach the maximum height. That is number one. B, calculate the total time spent by the body in air. That's the total time of flight. C, calculate the maximum height attained. Maximum height attained or reached. Calculate the maximum height attained or reached. And number D now, calculate the velocity. Calculate the velocity or the speed. Calculate the speed. Calculate the speed. Calculate the speed of the body at t equals 3 seconds. These are some of the way of asking question. Or E, let me add E. Calculate the height attained. Calculate the height attained at 2 seconds. At t equals to 2 seconds. Calculate the height attained at t equals 2 seconds. So let's see solution to the problem. Time taken to reach the maximum height. There is no problem with this. That is u all over g. Thank God u is given to be 50 meter per second divided by 10. Take 10 to be 10 meter per second squared. Then cancel, you have 5 seconds. You have 5 seconds. That's the time taken to reach the maximum height. B, total time spent in air. That's the capital T. I've told you something as 2t. So just multiply 2 times 5. That's going to give you 10 seconds. C, calculate the maximum height attained. H is equals to u squared all over 2g. We have derived this. U, 50 squared all over 2 times 10. That is 52500 all over 20. So this one gives you 125 meters. That is the maximum height attained. Now look at the speed. Calculate the speed of the body at t equals 3 seconds. You know the speed will be 0 at maximum height, but at 3 seconds it has not attained the maximum height. It only attained the maximum height at 5 seconds. So at 3 seconds, maximum height has not been. So it has a velocity or speed at that point. D part of the question. We have to find D part of the question. Find the speed by using V is equals to U plus 80. V9 is equals to U minus GT. This one is never equals to 0 at 3 seconds because the maximum height has not been attained. It is only attained at 5 seconds. So for that reason, initial velocity still remains 50. This is 10 times our t. They say at 3 seconds. So V is equals to 50 minus 30. V9 is equals to 20 meter per second. That's the speed and so time. E, we have to find the height attained at 2 seconds. Remember, I said you can use S is equals to UT plus half AT squared. This same thing as H is equals to UT minus half GT squared. H9 is given to be, what is U? U now is, our U is 50. Our time now is 2. It's given to be 2. Minus half times 10. Then times T. T is 2 seconds. 2 seconds. All this height is not maximum height. It is only maximum height. H is equals to 50, 100 minus 5 times 4. So this will be 100 minus 20. So h now will now be 80 meters. That is the interpretation of that question. So the next thing we are going to want to see example 2. Under example 2, a particle is projected vertically upward at 50. Okay, let me use 30 meter at 30 meters per second. At 30 meters per second. At the speed. Calculate the time taken to reach the maximum height. Time taken to reach the maximum height. B, maximum height attained. Maximum height attained. C, find the speed of the particle. Find the speed of the particle at t equals 1.5 seconds. And D, find the speed, find the height attained at t equals to 2 seconds. These are the questions we want to consider again. The first one, solution. You know that u is given to be 30 meters per second. 30 meters per second. So what you need to do here is to use t is equals to u all over g. That is 30 all over 10. This one will give you 3 seconds. B, maximum height, h is equals to u square all over 2g. That is 30 square all over 2 times 10. This one will give you 900 all over 20. That is 45. Give 45 meters. Then C, the speed. You use V is equals to U plus AT. That is V is equals to U minus GT. Because the speed is not at maximum height, but the speed is only 0 at maximum height. So V is equals to what is U? U is given to be 30 minus 10 times 1.5. So this one will be 30 minus 15. So the answer will be 15 meter per second. 50, that is D. We have to find the height. Remember, you use S is equals to UT plus half AT squared. This one H is equals to UT minus half GT squared. They mention when T is equals to 2 seconds. H is equals to, this one will be 30 times 2 minus half times 10, then times 2 squared. H is equals to 60 minus 5 times 4. H is equals to 60 minus 20. H is equals to 40 meters. This is another example. Example 3, the last example I will give you, we have it in 1GCE, where the diagram was drawn like this. We are given the diagram. We have the graph like this. We have the graph like this. They mention this to be V in meter per second. They mention this to be T in seconds. So you are not given any value here, but you are given a value here. This value, they call it, this one starting from 0, they call this to be 4 seconds. This is to be 4. Then you have to find the initial velocity of the object. Find the initial velocity of the body projected vertically upward. Upward. You can see this one represents u in the diagram. This one represents small t. This one represents capital T. That is time of flight. This one represents total time of flight. Time of flight is given to be 4 seconds here. Say 4 seconds. 4 seconds. And t is equals to 2u all over g. So 4 is equals to 2u all over g. Here you can say 4 is equals to 2u all over 10. 2 are 5. 4 is equals to u all over 5. When you cross multiply, you have 4 times 5, and you are going to have it to be 20 meter per second. This is the end of upward motion. So our next video, we are going to look at downward motion. All what you need to know as far as downward motion is concerned. Please comment, subscribe, like, and share. God will bless you as you do that.